All right, Honors Algebra 2, this is kind of our last topic in this chunk of notes before we kind of move on to some new stuff next week. We are talking about absolute value inequalities. So we have talked about absolute value, we've talked about inequalities, and now we're just kind of going to mash it up together. So the first thing I want you to think about is we know that absolute value has everything to do with distance, right? Absolute value has everything to do with the distance from zero in a lot of cases. So let's read this question. I'm saying the absolute value of a number needs to be greater than 5. Think to yourself, 5 away from 0. So what numbers are greater than 5 away from 0? Here's 0. Well, numbers that are this way, greater than 5, and numbers that are less than -5. Right? They have a distance of greater than 5 away from 0. Let's try another one. What numbers have a distance from 0 that is less than 2? Well, here's my 0. Well, if it's less than 2 this way and less than 2 this way, we're going to have open circles because less than. It's everything in there. So you can see the difference. The greater looks like little boat oars, and the less than looks like a little dumbbell here. So let's try another one. Okay, the distance from 0 has to be less than or equal to 6. So let's see. Less than 6 on this end. So it's all these numbers. And less than 6 on this end. So you can see I'm going to have closed circles because of that equal to, and it looks like a dumbbell again. All right, and I bet you can guess what this one's going to look like. The distance from 0 of a number has to be greater than or equal to 3. So let's see, it has to be bigger than 3 on this side and bigger than 3 away on this side. I'm going to have closed circles, and they're going away. So hopefully you notice that less than and less than are equal to, if there's an X on the left side, think less than. It's like an and situation where two things have to be true at the same time. That's going to look like a little dumbbell. Always less than looks like a little dumbbell. And then if you have a greater or a greater than or equal to, think greater. Think that's an or problem. And it looks like a little boat oar. And again, these could be filled in or not, depending on the situation. So my question for you is, can an absolute value inequality have exactly one solution? So this is hard. You're thinking, is there ever going to be an absolute value inequality where there's only one solution? You can see up here, right? There's lots of solutions up here, right? Every single number that is kind of colored is a solution right there. So is there one where there's exactly one? And the answer is yes. The absolute value of x is less than or equal to 0. The distance from 0 is either less than or equal to 0. Here's why this only has one solution. The only number that works for this is x equals 0, right? Because the distance from 0 is equal to 0. Anything bigger or more negative than this is going to eventually have a distance from 0 that's bigger than 0. So this is the only absolute value inequality that has exactly one solution. Can an absolute value inequality have no solutions? Absolutely. Look, the absolute value of something is less than 0, right? This is saying, can the absolute value ever be negative? No, right? So this has no solution. So here's kind of our summary. We're going to kind of sum things up. If it's greater than a number, it's going to have, it's going to be an or, and it's going to look like this. It's going to have ors. It's going to look like that or like that. Over here, if it's less than, it's going to look like an and inequality, and it's going to look like this, or it's going to look like this. Okay? And then you have to be really careful about that other number on the other side. So we'll see some examples of that. So let's go ahead and try a couple. Solve and then write your answer in interval notation. So we'll kind of use what we learned yesterday in the video. Okay. 2x plus 1 When is that less than 11? So let's see. The distance, 2x plus 1. When is that less than 11? And here's what else you do. When is that greater than negative 11, right? This is a less than problem. So we're trying to find all the values less than a number and then bigger than a number, right? So you go ahead and solve them. So what you're going to do is you make the opposite side negative and you flip the sign. Those are kind of the strategies here. So subtract 1, you get 2x is less than 10. So x is less than 5. That's good. Subtract 1, 2x is greater than negative 12. So x is greater than negative 6. So let's graph that. And I'm going to erase this eventually. Actually, no, I'm not. It needs to be less than 5, but greater than negative 6. Oops, and that needs to be an open circle. Okay, so this is kind of my answer, right? This is an and, but it says write the answer in interval notation. So let's see. The farthest left point is negative 6. The farthest right point is 5. And then go ahead and do open parentheses to signify that it's not equal to. All right, let's try another one. All right, negative 3x plus 10 is greater than 7. Okay, so we're going to try this. We're going to do our two kind of situations. I'm going to do them like that. So I'm actually going to maybe skip some room here. Okay. All right, so we're going to set negative 3x plus 10. When is that greater than 7? And we're going to do negative 3x plus 10. When is that less than negative 7? Because remember, when it's an and, greater, you're going to have like one end over here and one end over here. So we have to kind of create those two ends. So I'm going to subtract 10 and then divide by negative 3. Remember, when we divide by a negative number, we flip. So x is less than 1. That's one part of my solution. All right, then I'm going to subtract 10. We're going to get negative, let's see, 17. Divide by negative 3. We're going to flip the sign. So we're going to end up with just 17/3. And that is about, let's see, that's like a 5 point something, okay? So then we're going to graph it on the number line to help us with interval notation. It's less than 1, right? But it's greater than 17/3. So it's going to look something like that. So let's write that in interval notation. Let's see. The farthest left point, is negative infinity. And then it travels, stops at 1. Open circle. It starts up again at 17/3 and goes to infinity, right? All of these are open parentheses because they're open circles. And then we just stick a union in the middle. And that is done. Okay, I'm going to do number 3. I'm going to scoot it down and do it down here. All right, number 3. Okay, so this is number 3. I'm going to write number 3 again. Negative 2, absolute value of 3x minus 7 is greater than 6. Okay, let's try that. Divide by negative 2, the absolute value of, the absolute value of 3x minus 7 is less than negative 3. So here's what you have to think. Can I have an absolute value be less than negative 3? No. So this is a no solution. So you kind of have to think it through. If it's ever less than a negative, that's a no-go. So maybe make a note to yourself. Less than a negative number is a no solution. If it's greater than a negative number, we'll see what happens there in just a moment. So let me do number 4. Number 4 says 2x plus 3 in the absolute value plus 6 is greater than 0. Well, we need to get the absolute value by itself first. Absolute value of 2x plus 3 is greater than negative 6. Well, when will the absolute value be greater than negative 6? Won't it always be positive? So this is going to say all real numbers, right? So, and the way that we write that in interval notation is to go from negative infinity all the way to infinity. So you can see these are our two kind of weird situations. If it's less than a negative number, you'll have no solutions. But if it's greater than a negative number, you'll have infinitely many solutions, right? All right, let's try one more example. I'm going to do question number 6 here. 6 times the absolute value of negative x plus 5 is less than 6. Divide both sides by 6. We get less than 1. So this is a situation where we don't have to worry about it because this is not negative. So we're going to get some answers here. But don't forget that we need to kind of do that double, kind of two, there's going to be two situations. So negative x plus 5 could be less than 1, and negative x plus 5 has to be greater than negative 1. So those are my two situations. Remember, you flip the sign and make it negative on the other side. So let's see, subtract 5, divide by negative 1. Flip. So that's our first answer. Subtract 5, divide by negative 1. Flip. And since this is a less than, it'll be an and problem. So x has to be greater than 4, open circle, and less than 6. So you're going to get it stuck right in between there. And then how do we write that in interval notation? Well, it's pretty easy. It's just 4 to 6. And you are all done. And that is it. So if you have questions on this, be sure to kind of connect with me and we can find a time in office hours. We can do these example problems. We can find some more. I know that this is a little bit tricky. If you want to YouTube more questions, you can also do that. Just look up